Hello everyone. You're watching my YouTube channel Chemistry by Saad, and this is my WhatsApp contact number. You can contact me for my one-on-one individual coaching lessons, and I am your coach, chemistry coach. I have been teaching chemistry across the globe, and today this is lesson number 3. And what we were discussing previously, we were talking about speed of reaction. Let's start our topic, speed of reaction. Here is a graph, and I want to explain something from this graph. You guys can see this graph probably, and I want to explain something from this graph. This is the textbook for IGCSE chemistry. I am using different textbook, and this is a curve here. See this part of curve, this curve steepest. When curve, remember, when curve is steepest like this, when curve is steepest, when curve is more steepest, it means reaction is fastest. And when the curve is less steep, it means reaction is slower. And when the curve is flat, horizontal line, straight, it means curve flat, reaction is over, reaction is stopped. Now game is over. So guys, what we are discussing today now, changing the rate of reaction. This is part 2. I have uploaded part 1. I suggest you guys do watch part 1 as well. And in today's topic, we will talking about how reaction rate will be affected when we change the surface area. Means by changing surface area, how this influence the rate of reaction. You can read from this book. What I am going to do, I am just explaining this topic by the diagrams, and I am just trying to deliver the concept, right? Like, remember guys, when surface area is high, when surface area is high, when surface area high means greater surface area, then the rate of reaction is high, greater rate of reaction. We can say surface area directly proportional to rate of reaction. Surface area directly proportional to rate of reaction. High surface area means rate of reaction is high. And remember, like this is a big piece and this is a smaller piece, smaller pieces. Remember guys, when there is a big piece, remember, very important point I am going to share with you guys here. Big piece means less surface area. Big piece means less surface area. And smaller piece means more surface area. Very important point I am going to share with you guys here. More surface area. Big piece, this is big piece, reactant can just react here. But here, these are smaller pieces. Surface area is high, reactant can goes here, reactant can enter here, reactant can goes here. It means more reaction, while just reactant can stay here at the surface. So big piece, big substance, less surface area, and less surface area, rate of reaction is low. Smaller pieces, more surface area, rate of reaction will be high. Like here, this is an experiment 1. Here we have big piece of marble chips. This is actually calcium carbonate. This is again calcium carbonate. But here calcium carbonate is in the form of small piece, small marble piece, marble chips. Big large chips. So surface area is their surface area is the total area of exposed surface, but the chips are small, so the surface area is greater. Remember, smaller pieces have greater surface area, guys. So this is experiment 1 and experiment 2. Now let me explain, let me show the result of this experiment. So this is loss in mass. What loss in mass? Where is reaction? Reaction is somewhere here. When calcium carbonate is reacting with, okay, the reaction is when calcium carbonate What calcium carbonate? This is marble chips. Marble chips. When calcium carbonate react with HCl, 2 mole of HCl, we will get calcium chloride. We will get carbon dioxide, and we will get hydrogen gas, right? So it means as the reaction goes, the mass of reactors will decrease. So loss in mass, mass of reactants will decrease, loss in mass. Why mass of reaction will decrease? Because now the reactants start converting into product. So the mass of product will increase. Mass of product will increase. But guys, mass of reactants will decrease. So, and what we have to figure out here, we have to figure out we have experiment 1 and we have experiment 2, and we have to figure out in which experiment loss of mass, loss of reactants mass takes earlier. Means in which experiment loss of reactant mass will take less time. Like here, see this graph carefully. 2 gram loss, 2 gram loss, and time taken for this 2 gram loss, you can say 3.5 minute. So in experiment 2, where we are using small chips, experiment 2 where small chips. So 2 gram loss, time taken 3.5 minute. Okay, now see this is again 2 gram loss, but the time taken for 2 gram loss is here, you can say 5.5. So in experiment 1, where we are using large marble chips, and for 2 gram loss, time taken will be 5.5. It means reaction is faster when we use small chips, because when we use small chips, it means more surface area. More surface area means rate of reaction will be high. It means time taken to complete this reaction, or time taken to complete this reaction will be less. In less time, more reactant will convert it into product. So this thing I want to share with you. Now all these things are explained here, and I am going to highlight few important lines, and I suggest you guys do highlight these lines as well from your textbook. No matter which textbook you guys are following, using, the rate of reaction increased when the surface area of solid reactant increased. As you have seen, you can increase the rate of reaction by increasing concentration of reactant, by increasing temperature, by increasing surface area. In some situation, an increase in any of these can lead to a dangerously fast reaction. You get an explosion. Here are some examples. Okay, let me discuss some interesting things with you as well. Explosion. Usually we think that explosion takes place in metals, but remember, explosion takes place also in non-metals. Like in flour mills, flour particles are tiny, so flour has a very large surface area. It can also catch fire. In a flour mill, if there is a lot of flour dust in the air, a spark from a machine could be enough to cause an explosion. For the same reason, explosion are a risk in wood mills from wood dust, and in silos where wheat and other grains are stored. And in factories that make custard powder and dried milk, this dust form, all these will burn because of high surface area. The reaction reaction can be explosion reaction. In coal mines, very famous, because in coal mines explosions are very famous. Okay, oh, very dangerous. So the next is collision theory, and I will explain this collision theory in the next video. And I need your comment and I need your suggestion. You can contact me for my online tutoring services. And I suggest you guys, I request you guys, do share this video with your classmates. Okay, goodbye.